About how to find different angle measures and use angle measures to solve real world problems, okay? Remember, this unit is about trigonometry, okay? And trigonometry expands way beyond just a right triangle, okay? You have 9 right triangles. You have the actual graphs of the functions like sine and cosine and tangent, okay? You have this concept called the unit circle. You have reference angles. There's so many other things about trigonometry that are not just right triangles, okay? So the first lesson of this unit was all about right triangles. That's what you learn in geometry. Now we're starting to go into the pre-calc part of it all, okay? So, like I said, you're taking notes yourself. I expect you to be taking smart notes, okay? So make sure you listen, see what's on the board, and then get what's important. Trust me, not everything should be written down. Do not write down everything, okay? All right. So, to start, let's talk about what you knew versus what you now need to know, okay? On the left, you see what's on the left? That's an angle. That's what you did back in geometry. When you first learned about geometry, you learned what an angle was, okay? It had a vertex, and then it had 2 rays that composed the sides, okay? Well, those sides have a special name, okay? You have what's known as your initial side, and then you have what's known as your terminal side, okay? When you put that angle into a coordinate plane, like what is on the right-hand side, okay? You now have put that angle in standard position. The vertex is at the origin. The initial side is on the positive x-axis, and then the terminal side is somewhere inside of that coordinate plane. For this particular example, it is in the first quadrant, but it doesn't necessarily have to be in the first quadrant. Okay? Sometimes you'll be asked to draw an angle in standard position. Okay? When you do that, again, you need to remember a couple of things. One, the vertex is located where? 0, 0. Is at 0, 0, the origin. Okay? And then the initial side will always be on the positive x-axis. Okay? The initial side will always be on the positive x-axis. The terminal side could be anywhere else in quadrants 1, 2, 3, or 4. Let's review quadrants real quick, okay? What quadrant is this? This one is 3. What's this one? 1. Which one is 2? The one on the left or the one on the bottom? Very good. Just to make sure. Okay? Now, the measure of an angle describes the amount and the direction of rotation necessary to move from the initial side to the terminal side of the angle. In other words, when you create an angle, okay, you have your initial side. Okay, if it's in standard position, it's always on the positive x-axis. Your terminal side is what creates the angle because that's the one that moves. If you happen to draw the angle going in the counterclockwise direction, you basically created a positive degree angle. However, if you draw it and you go in the clockwise direction, you created a negative degree angle. Okay? So, for example, if I went in the counterclockwise direction to create this angle, this could be potentially 120 degrees. Okay? But if I went in the clockwise direction, that would create a negative angle, and that would be negative 240 degrees. Okay? Now, if you look at those two numbers, I didn't just arbitrarily pick those numbers. 240 and 120 add up to equal what? 360, okay? So if you do happen to draw an angle, technically you've created two different angle measures. If it went counterclockwise, it's 120. Clockwise is negative 240, okay? And you always specify like the direction in which you're going by those markings. Okay, so those curve markers will indicate, okay, this angle originally went in the counterclockwise direction or in the clockwise direction. So make sure you include that as well. All right? There's a lot of words on this page right here, and I'm not expecting you to write every word. Okay? Get what's important. There are such things called reference angles. Okay? Reference angle is an acute angle formed by the terminal side of a given angle and the x-axis. Okay? You can have a reference angle in all four quadrants. And if you happen to have a reference angle in quadrant 1, then it is its own reference angle. No matter what, reference angles are always positive. And then this diagram that you see here basically gives you the reference angles. Okay? Real quick, and everybody stop writing. I just want you to look. Quadrant 1. There's an angle that's in the first quadrant. Its reference angle is the measure of that angle. But if you have an angle in quadrant 2, represented by the 120 degrees, the reference angle is, again, it's the acute angle between the terminal side and the x-axis. It's always acute. What angle measure do you think this is right here on the negative x-axis? How many degrees is that? If I go from here to here, how many degrees is that? 180, half of a circle, right? So 60 comes from doing 180 minus 120 is the remainder to get there. Quadrant 3, you have 240 degrees, okay? 240 degrees is a little bit more than 180, but again, it is the acute angle between the terminal side and the x-axis. So you subtract those two. Quadrant 4, 315 degrees is the angle. If I go a full circle, how many degrees is that? 360. So 360 minus that angle will give me my reference angle. Again, no matter what, your reference angle is always acute. Always acute. Okay? And then this down here basically describes how, basically what I just did there. So here are a few examples. We're going to find the reference angle for these few examples. So we're going to do some that are going to be like for your notes, and then we're going to do some that are going to be on your desk, okay? So we're going to find the reference angle for each one of these, okay? The one that's given to you in the picture is 1 as well, okay? It is 1 as well. But let's start off with the ones that don't have a picture associated with it. 120. 120. That's kind of easy. What is it? What's the reference angle? It's 60. I say it's easy because it was just on the other page, okay? But if you wanted to graph it, here's your x, here's your y. 120 degrees is going in the counterclockwise direction, so it lies in quadrant 2. So then this is your reference angle, and that is 60 degrees. What about 200? What quadrant does 200 lie in? 3. Quadrant 3. And that's if I go, again, in a counterclockwise direction, 200 degrees. So if it's in quadrant 3, I need the acute angle. It's what? Ooh, remember, it's always with the, which axis? The x-axis. So if it's 200 degrees, what angle is right here? 180. So what's the difference between 180 and 200? 20. So that is a 20 degree angle. The picture doesn't show 20 degrees clearly, but things are drawn to scale. 400. Where's 400 at? Say it again. It's around again. Think about it. If I go around one full time, how many degrees is that? And there's no rule that says I have to stop at 360. There are several angles that are infinitely big. So I can keep going multiple times around. But 360 is very close to 400, so I am in the first quadrant. So you can go around and around and around as many times to create these angles. But still, yet again, the reference angle is always acute. So how many degrees is that?
40.
It's going to be 40. How'd you get 40?
360. 160.
Very good. Because if you've gone around one time, you've already gone 360 degrees, so the remainder would make 40. And again, just like how you can go around multiple times to create larger angles, you can also go in the counterclockwise direction, which we have done in this diagram here. Okay? I want to know my reference angle, which again is the angle that's between the terminal side and the x-axis. How many degrees is that, you think? Always gotta be positive. How far is that terminal side from the x-axis?
What was the question?
It's 50 degrees. I asked how far was the terminal side from the x-axis? And it is 50 degrees. How? How is it 50 degrees? You say you did what?
230 minus 180.
And then you knew that it still had to be positive. Yes. Okay? Just like how when you're going in the counterclockwise direction, you have 0, 90, 180, 270, and then 360. It works the same way going in the clockwise direction. This is 0, this is negative 90, this is negative 180, negative 270, negative 360. And we can keep going on and on and on. Okay? But again, no matter what, it's still the distance. How far is that terminal side from the x-axis? You could do 230 minus 180. And at the end of the day, no matter what, your reference angle always has to be positive. So it's 50. Question on any of these reference angles? Okay. Coterminal angles. All about angles today. Coterminal angles. By defining angles in terms of their rotation, two angles can have the same initial and terminal size but different angle measures. These are called coterminal angles. That very first angle that I drew out for you that was 120 and 240, those were examples of coterminal angles. They had the same initial side and the same terminal side, but because one was counterclockwise and the other one was clockwise, it created two different angles. They are called coterminal angles. So two angles that have the same initial side and the same terminal side are called coterminal angles. And here's an example that you see down the bottom. The one on the left shows three coterminal angles. One angle is 60 degrees when I go in the counterclockwise direction. The other one is negative 300 degrees. That's if I go in the clockwise direction. Now remember how I said you can go around and around and around to create angles? Well, if I go around one whole time and two whole times, and I end up right back at that same terminal side, I have 780 degrees. That too is a coterminal angle. .360 degrees create coterminal angles.
So any angle as long as it has the same terminal side and initial side?
So if you look at 60, if you were to minus 360, you get negative 300. That was one of your coterminal angles. Coterminal angles are always separated by 360 degrees, okay? If I did 60 plus 360 plus 360, that's how we get 780. 2 full rotations and then 60 degrees. Coterminal angles are always separated by 360 degrees. Could you guys give me another angle? Give me another angle that's coterminal of 60 degrees that's not already on the board. Say again. 420. You get that coterminal angle by adding just one 360 degree angle. Sorry, 360 degree rotation. So that 2 is a coterminal angle. You can continue to add as many multiples of 360 degrees as you like to get multiple coterminal angles. Or you can subtract 360 degrees to get as many negative coterminal angles as you like. Okay? Now this one over here, this is what I was talking about on Tuesday. Angles are not just measured in degrees, they're also measured in radians. This is an example of 2 coterminal angles in radians. Okay? Radians involves pi. Not 3.14, not 22/7, the irrational number pi that doesn't end. Okay? So, in this case, you have 7 pi over 4 and negative pi over 4. Since coterminal angles are created by adding 360 degrees, you need the corresponding radian measure that represents 360 degrees. Does anybody happen to know what that number is? It is 2 pi. 2 pi radians is equal to 360 degrees. So if you have an angle that's in radians, to find its coterminal angle, you would either add or subtract 2 pi every time. So if I have 7 pi over 4, and I subtract 2 pi, first off, how do you subtract a fraction from a whole number? Say again. Say it again. I still can't hear you. How do I subtract a fraction from a whole number? What do I need? I need a common denominator. I cannot hear you. So one more time for the good time. How do you add a fraction to a whole number?
Common denominator.
Thank you. Okay, what is the common denominator here?
4.
4. What would I have to multiply 2 pi by to get a 4 in the denominator? That's probably was a confusing question. I'll admit on that one. What would that turn into to make it so that it's a 4 on the bottom? And 8 pi. So what's 7 minus 8? Negative 1. If you notice, pi is almost like a variable here. It's not that number. It's not that irrational number. Okay? Treat it as such when you are trying to find coterminal angles. Okay? 7 over 4 minus 2. That's why I asked about the whole fraction and the fraction and the whole number thing. Okay? I want you to practice. On your desk, I want you to identify one positive and one negative angle coterminal with a 126 degree angle. I want you to do this on your desk. If angles are coterminal, that means you're going to either add or subtract what number? 360. In this case, because it is an angle that's given to you in degrees. So you can take 126 and add 360 to it to find another coterminal angle. So that's 486. So right there, it kind of eliminates all your options. Okay? Or you could have done 126 and did what instead? Subtract 360. Okay? So then it would have been a negative 234. So your answer would have been A. Okay? All right? An angle, any angle has infinitely many coterminal angles and is found by either adding or subtracting integer multiples of 360 or 2 pi. Integer multiples, okay? Let's go back real quick to this example, okay? You see how I added 360 twice, okay? I really could have just said 360 times 2 and then added 60 as well, okay? So, integer multiples, as long as you multiply it, you can say 2 360s, 3 360s, 4 360s. You're doing integer multiples. You would never do half of a 360. That's not a coterminal angle, okay? If your angle given to you is in degrees, you want to add multiples of 360, but if it's given to you as radians, you want to add multiples of 2 pi. So how's that written? That is 360 n or 2 n pi. That alpha, which is a Greek letter that looks like an A, that alpha just represents the original angle given to you. That is how you find as many coterminal angles as you want. Just say you find all of the coterminal angles. So if your angle was pi over 3, and you were asked to find all of the angles, all of the coterminal angles to pi over 3, first off, is this degrees or radians?
Radians.
It's radians. You would just add 2 n pi, and that would be your answer. Okay? If you want to go to the next step, you can even say that n is an element of what symbol that represents integer? It is z. Okay? That's how you represent all of the coterminal angles to pi over 3. Let's look at some examples. We're going to identify all of the angles that are coterminal to the given angle. Then we're going to find and draw one positive and one negative coterminal angle. I'm going to do these two with you. I want you to try the next two on your own. So to start out, 80 degrees. What quadrant is 80 degrees located in? Quadrant 1. Okay? And since it is a degree to represent all of the coterminal angles, it's going to be 80 plus what? 360 n. Very good. So this represents all your coterminal angles.
Do you want to put the n on before the
Go.
the n is an element. N is an element of energy.
You don't have to. You don't have to. Just when you use that formula to find other coterminal angles, promise me you'll use integers. Okay, so make sure you use integers. Because that's what we're going to do. We're going to find one positive and one negative coterminal angle based off of 80. Okay? What integer do you want to use? Give me an integer. Doesn't matter. 1. Okay? So we're going to use the integer of 1, and that's probably going to give me my positive coterminal angle. Give me another integer. Negative 1. Those are your two easiest ones. Okay? So if I plug in 1 here, that's basically 80 plus 360. What's 80 plus 360? 440? Okay, 440. That's going to be the first angle I'm going to draw. I'm going to draw it in blue. No matter what, coterminal angles, they have the same initial side and the same terminal side. And if you know where 80 degrees is located, then you know exactly where 440 degrees is located. And what quadrant was it located in? 1. So I'm going to draw a straight line in the first quadrant. Doesn't have to be exactly at 80 degrees. It just better be in that first quadrant. And I'm going to draw the curve to mark 440 degrees. Remember, you start on the positive x-axis You go counterclockwise to represent a positive angle. So far, how far have I gone?
360.
So then I just need to go the remaining 80, and there's my 440 degree angle. If I use -1, I'm basically saying 80 minus 360. What's 80 minus 360? -280. So I'm going to draw that one in this kind of tannish color. Again, I still start at the x-axis, the positive x-axis. At this time, I'm going to go which direction? Clockwise. And I'm going to end at my terminal side. And that's 280 degrees. That is how you find and how you draw coterminal angles. Let's look at B. -3 pi over 4. Actually, is that in radian or degree? So to represent all the coterminal angles, I'm going to do -3 pi over 4 plus 2n pi. As long as you remember it's 360 and 2 pi, you can attach it in, and then you have all of your coterminal angles. Somebody give me an integer for n. Okay, let's do something different. Now, for your homework, you're more than welcome to use 1 and -1. It's fine, totally fine. For drawing's sake, let's use 3 for that n, and then somebody give me another one. -5. Okay. So when I plug in 3, what's 3 times 2? 6. So this is going to be -3 pi over 4 plus a 6 pi. Again, how do I add a fraction to a whole number? Common denominator. My common denominator is going to be what number? 4. So then 6 pi is going to turn to what pi over 4? What's -3 pi plus 24 pi? 21 pi. So 21 pi represents the positive coterminal angle. But now here's the question. Sorry, the positive coterminal angle when I've gone around 3 times in the counterclockwise direction. I always mix them up, so I apologize. Where is -3 pi over 4 located? Does anybody have an idea? If this is my x and y axis, I know this is 0, 90 degrees, 80 degrees, 270 degrees, 360 degrees. In degrees, okay? But in radian, 360 degrees is how many radian? 2 pi. So then what's half of that? And since 90 degrees is technically half of 180, this one up here is going to be what? Half of pi. That's pi over 2. Okay? So I start at 0. I go half a pi. I'm at a full pi. This one down here is how much? What number is halfway between 1 and 2? What's that as a fraction? As an improper fraction. 3 over 2. So this is 3 pi over 2. Okay. Now mind you, every single one of these came from me going in the counterclockwise direction. So, going in the clockwise direction, I still start at 0. This one is going to be what? Don't overthink it. Negative. It's negative pi over 2, because it's the exact opposite. I'm just going in the negative direction. This one is going to be negative pi. This one is going to be, and this one all the way around is going to be a negative 2 pi. So, if the positives was throwing you off, just look at the numbers in front, okay? You have 0, negative 1 half, negative 1, negative 3 over 2, negative 2, if you go around. So, negative 3 pi over 4 is in between what numbers? Negative pi and negative pi over 2. So, negative 1 and negative 1 half, right? So, that would be in the third quadrant. So to draw this 21 pi over 4, I need to start on the positive x-axis. I need to go counterclockwise 3 times. 1, 2, 3, and then I need to end at my angle. Not only does n represent the integer that you're going to use to find the coterminal angle, it also represents the number of times you're going to go around. But no matter what, you always start where? On the positive x-axis, at that 0 angle. And if I'm going to do a positive angle, I need to go which direction? Counterclockwise. All right? Let me bump this one down to, let's do negative 2 instead. What's negative 2 times 2?
Negative 4.
So this becomes negative 3 pi over 4 minus a negative 4 pi. Can y'all see that in the back? Okay. What's my common denominator still going to be 4? So you have negative 3 pi over 4 minus 16 pi over 4. And what is that? What's negative 3 minus 16?
Oh, negative 19.
Negative 19 pi over 4. Again, my angle is in the third quadrant. That was where negative 3 pi over 4 was. But this time, when I draw my curves, I start at the x-axis, of course. And I go which direction?
Clockwise.
Clockwise. How many times am I going to go around? Say again. 1, 2. But I have to end in my terminal side. I have to end in my terminal side. Try this one on your desk. Not that one. I want you to do just the negative 30 degrees. Just the negative 30 degrees. So to represent all coterminal angles to negative 330, negative 30, it's going to be negative 30 plus what? 360n. Then from there you can plug in any n value you want to get one positive, one negative. But the desk I saw, it seemed like everybody used 1 and negative 1. It's totally fine. Okay? You can use that. So when I plug in 1, what's the positive coterminal angle? When I plug in negative 1, what's my negative coterminal angle? Negative 390. Where is negative 30 located? What quadrant? 4. So then when I draw my 330, I should start where? Positive x-axis going counterclockwise, ending at my terminal side. For negative 390, my angle is still in the fourth quadrant, but this time when I start on the positive x-axis, I go which direction? Clockwise. I pass the first time, but then I end when I get back to it. Okay? Try 7 pi over 6. Do we figure out what quadrant 7 pi over 6 was in?
Third.
It is in the third, okay? If you take remember from that other drawing that I did on the other page, you had 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And I said if the pi's throwing you off, just look at the coefficients, okay? 7 over 6 is a little bit bigger than 1, right? Well, here's 1 pi, so it had to be in the third quadrant, okay? So that's where 7 pi over 6 was. That's where 7 pi over 6 was. Now, how do I represent all coterminal angles to that? 7 pi over 6 plus 2 n pi. Very good. Somebody give me a positive coterminal angle.
1.
Okay, and then when I plug 1 in, what was the angle?
9 pi over 6.
Very good, because it would have been 7 pi over 6 plus 2 pi. You needed a common denominator, which was a 6. So then that became 12 pi over 6, which was 19 pi over 6. Very good. So that means I'm starting at the positive x-axis, going counterclockwise around, and ending there. Very nice. Somebody give me a negative coterminal angle. Negative 1. So then that would have been 7 pi over 6 minus 2 pi. Again, common denominator. So what did you get? Did anybody use something different? Mm-hmm. Because it's less than that 2 pi. Yep. Coterminal angles, questions? Yes.
I just don't know how many times to go around when it's in a radian.
Yeah.
Okay. It's similar to the. Well, I'll take it like this. If the angle given to you is already positive, and if you're always going to use 1 and negative 1, okay, if you're always going to use 1 and negative 1, and the angle's already positive, you're going to go all the way around and then in. Okay? But if you're trying to find the negative angle, you don't go all the way around.
You're just going to go until you hit the line.
You're just going to go until you hit the line. And then vice versa. If the angle's negative, then you're going to go around for the negative angle, but just till you reach it for the positive. So look at this one. Okay? You see here for this positive angle, we just went around to meet it. But for the negative angle, we had to go all the way around. So we had to pass it and then go all the way around. Okay. All right. Did that. We're at the foldable now. All right, so we're going to be talking about a few other types of measurements today. We kind of talked a little bit about degrees and radians. We're going to talk about degrees, minutes, seconds, and we're going to talk about arc measure. And so this foldable that you have here, I'm going to give you basically the formula to convert from radians to degrees and then degrees to radians. I'm also going to give you a formula to convert from degrees to DMS, which is degrees, minutes, seconds, and vice versa. And then, of course, your arc length formula. And that's going to kind of wrap up today. Okay? So to convert from degrees to radians, all you do is you multiply the radian measure by 180 over pi. That is the formula. 180 over pi. And that's how you'll take a radian measure to a degree. So if you're given a radian, you just multiply it by 180 over pi. And the purpose of it is that it's supposed to cancel out your pi's. That's why the pi is on the denominator. Because when you have a pi at the top and a pi at the bottom, they cancel. Okay? Now, you can sit there and you can multiply 11 by 180 and then divide by 6. Or you can continue that same trick of canceling out things that are in common. Can't 6 go into 180? How many times? 30. So I can actually reduce this prior to me multiplying, okay? Because I can't guarantee that maybe on this section of the test that you'll have a calculator, so you want to try to get it down as low as possible, okay? And if you're like, well, I don't know what 30 times 11 is, yes, you do. Because you know what 11 times 3 is, correct? What's 11 times 3? 33. You just add a 0 at the end. So 11 pi over 6 is equivalent to 330 degrees. Let's do the next one. To convert, I multiply by what? What happened to the pi's? They cancel. Does 2 go into 180?
Yes.
How many times? 90. What's negative 3 times 9?
Negative 27.
And then you just add a 0. Will it always happen that way? No, it really just kind of depends on how they simplify, but you're worried that you can't multiply these. What do I multiply by again?
180 over 5.
What happened to the pies? Does 3 go into 180? How many times? What's 60 times 40? Are you guys getting the drift?
Yeah.
Good stuff. I don't even want to do that last one. Let's go to the other way. Going from degrees to radians. Unless there's questions. So going from radians to degrees is 180 over pi. Anybody want to take a guess of what it is to go from degrees to radians?
Pi over 180.
Very good. Pi over 180. Okay, and you're still multiplying. Okay, we want to get the pi this time. So we're going to, well, the first one you guys should already know. But we're going to multiply by pi over 180. Okay? It's the same thing as basically saying it'd be over 1. Doesn't 180 go into 360? How many times? 2 times pi is? Y'all should already know that one. Y'all should already also know 180. No? Okay. All right, let's multiply by pi over 180. This is basically like saying 180 over 1. How many times does 180 go into 180? Once. So then this is nothing but 1 times pi, which is just pi. See how it works out? Nice and easy. Continue to multiply by pi over 180. Put that number over 1. Now this one's a little bit different. 90 does go into 180, doesn't it?
Yeah.
But this time the 90's gone, the 180 turns into a 2, so this is just pi over 2. Excuse me, let's do negative 45. I'm going to multiply by pi over 180. What number goes into 45 that also goes into 180? 5. Anything bigger? Does 9 go into 45? Goes into 180. Okay? It's a little bit bigger. So what is 180 divided by 9? 20. What's negative 45 divided by 9?
Negative 5.
So right now I have negative 5 pi over 20. Can I reduce that some more? Sure can. Now if you're like, I can't notice that the big numbers, that's fine. Just continue to divide by whatever number you can see until you can't simplify anymore. How does 5 over 20 reduce?
Negative pi over 4.
1 over 4, so negative pi over 4. Let's do 120. If I multiply that by pi over 180. You see how both of these have a 0 at the back end? You can cancel that out. Yes, you can cancel that out. What number goes into 12 that also goes into 18?
6.
What's 12 divided by 6? 2. And 18 divided by 6?
3.
I don't remember what the number was. That's how you convert from degrees to radians and radians to degrees. Pretty easy. To go to degrees, minutes, seconds, I don't think we need to do that one. Okay? Lots of words on this page. You do not need to write down everything, okay? But degrees can also be expressed using decimal degree form, which is known as degrees, minutes, seconds. Okay? Where each degree is basically subdivided into 60 minutes, and each minute is divided into 60 seconds. Okay? There are symbols that represent degrees, minutes, seconds. Of course, degree is the degree symbol. Minute is the apostrophe. Seconds is basically like the quotation mark. Okay? So, this is used like for GPS coordinates and things like that. So if you're like, where is this used? That's where it's used. Okay? So pretty much to convert a decimal degree to degrees, minutes, seconds, one thing that will always stay true is that number before the decimal, that is your degree. So that doesn't change, okay? So this number that's before the decimal will always be your degree, the D in DMS, okay? So that is 56 degrees. Now, this one, you're going to need your calculator for, okay? What you do from here is you take what remains, which is the 735, and you're going to divide it by 60. So somebody do 735 divided by 60. 12.25. The part that's before the decimal is your minutes. So then you do 12 apostrophe, that represents 12 minutes. And then one last time for the good time, you take what follows the decimal and you divide it by 60 again. What is that? Point what? 416. Okay. And so technically we would take the part that again that's before the decimal, okay, which is a 0. And so a lot of times you might have to round to like the nearest tenth or something like that. I think I'll tell you if you do have to round, but it is going to be that last little bit, and that is your seconds. So 56.735 degrees in degrees, minutes, seconds is 56 degrees, 12 minutes, and 0.4 seconds. It's kind of weird, but it works. Make sense? So you just divide by 60. You just divide by 60. All right. Messed up. It happens. It happens. This is actually how you go from degrees, minutes, seconds to decimal degree form. Is when you divide. I made the mistake to actually go from decimal degree to degrees, minutes, seconds. The correct way to go from decimal degree to degrees, minutes, seconds is you don't divide by 60, you multiply by 60. Okay? But one thing I did mess up on, that 56 is still degrees. Okay? So that 56 is still the degree. But I take what remains, okay? I take that remaining decimal and I include the decimal. And I multiply it by 60. So somebody tell me what 0.735 times 60 is. 44 point what? 1. Okay. So the part that again follows is before the decimal. That's actually your minutes. So I messed up there. So I apologize. And then to get my seconds, I take the remaining decimal again and I multiply it by 60. So what's 0.1 times 60? 6. So that's 6 seconds. So 56.735 degrees is 56 degrees, 44 minutes, and 6 seconds. So to go from decimal degree to degrees, minutes, seconds, you multiply the remaining decimal by 60 to get your next piece. Thank you for being understanding. Do this one on your desk. Do this one on your desk. What you get? D. It is D, okay? Hopefully you took that 0.275 and multiplied by 60 to get 16.5. So then that was your degree or your minute, and then you took 0.5, multiplied that by 60, and got 30, which was your second. Very good. Okay? Now the correct way to go from decimal degrees, minutes, seconds to decimal degree form is you divide. I'm so sorry, y'all. You divide, okay? You divide by 1 over 60, and then you divide your seconds by 3,600, okay? Because like you do it twice, you got to convert it from minutes and then the seconds as well, okay? So again, the degree stays the same. That is still 32, but you take the 5 and divide it by 60, and you add that to the 28 divided by 3,600. So in our calculator, that's what we're going to do. 5 divided by 60 plus 28 divided by 3,600. Give me 3 decimal places when you do it. What you get? 0.91111. That's the remainder. That's the rest. That's the decimal. Okay? Let's say that when you do this and you add it together, it ends up giving you something that was greater than 1, then you just have to add it to the 32. But I doubt that'll happen. Okay? But that's how you go from degrees, minutes, seconds to decimal degree form. Did everybody get this down? Divide by 60, divide by 3,600. All right. Last thing, arc length. Last thing, arc length is another angle measurement. Okay, you have the formula for arc length. It's basically a part of the circumference. It's the formula 2 pi r times theta over 360, where theta represents your angle in degrees. Or it's s times r theta if your angle is given to you in radians. Okay, they both do the same thing, except one is used when you're given the degree, and then the other one is used if you're given the radian. Okay. But arc length is a part of the circumference. R represents your radius of your circle. So if it asks you to find the length of the intercepted arc, it's asking for the arc length. Okay. When the central angle measure is pi over 3, and the radius is 4, round to the nearest tenth. So it's asking you basically to find this length here when the angle is pi over 3 and your radius is 4. Since the angle is given to you as a radian, you will want to use this formula. And so all you do is multiply your radius by your angle. And that's it. And since it's asking us to round to the nearest tenth, we would type that into our calculator. 4 times pi over 3. Does everybody see where your pi button is located? Okay, 4, parenthesis, if I press the second button, then this caret button right here, that's how I can get the pi. Then divide it by 3, close the parenthesis, we'll get our answer. Round to the nearest tenth, what is that? 4.2. Awesome. 4.2 inches. We covered a lot today.
Teachers, pardon the interruption.
We covered a lot, but tomorrow we're going to basically spend tomorrow's class period just practicing, okay? We're going to spend tomorrow's class period practicing pretty much everything we did today. But I want you guys to do this one on your desk. I want you to find the length of the intercepted arc in a circle with a central angle of measure of 125 degrees and a radius of 7 centimeters. Okay? Make sure you use the correct formula. Remember, you use the formula based off of the angle. If the angle is given to you as a degree, which it is, you have to use the formula 2 pi r, theta over 360. If you want, you can convert that to a radian and then use the shorter one, but it's pretty much the same amount of work. What's my radius? 7. What's my angle?
125.
And then you divide it by 360. You can literally type it in exactly how you see it. 2 times pi times 7 times parentheses 125 divided by 360. What did you get?
15.1 centimeters.
4? 3? 3 centimeters. Very good. Okay? Do this one on your desk. What do we get for our answer? Make sure you use the formula r theta here because theta, your angle, was given to you as a radian. Okay, so there's a difference between the two formulas. Make sure you use the correct one.
I had to put that in one.
Okay?
Oh my god.
One last formula, y'all. Get this one down. Get this one down. Okay? Slide in somewhere, either in on your notebook pages or in one of the available spaces. Area of the sector is basically like a piece of pizza. A equals 1/2 r squared theta. Theta is in radians. Okay? Theta has to be in radians. It has to be in radians. It has to be in radians. Okay? That's basically a part of the area of the circle. Okay? So make sure you guys get this down. We'll talk about this and practice this some more on Friday. Okay? But please make sure that you indicate that theta has got to be a radian. So if it's not a radian, what do you need to do? Convert it. Thank you.